Okay, today and tomorrow we're going to be talking about exceptions, which are, well, basically it's like, nothing can possibly go wrong, go wrong, go wrong. And the fact is that something inevitably goes wrong. And so what do we do about it? So okay, so today exceptions, especially this sort of try-catch thing. The difference between checked and unchecked exceptions, it's not so much the terminology, but how they're handled. Really, the important thing there is that an unchecked exception is something that's just going to happen, and a checked one is something that you have to explicitly deal with in the code. In other words, and we've seen examples of unchecked ones. The way to handle the checked ones and sometimes the unchecked ones is with a try-catch block, or possibly having the method throw an exception. There are different opinions about that. What I've finally landed on myself is that in 99% of the cases, I do use try-catch rather than throwing. It's throwing is kind of passing the buck and not taking responsibility, as it were. And sometimes it's necessary. The only times I've found it to be necessary are in fairly complex situations that we won't encounter here. And okay, and then so basically deciding whether to catch or throw or both. Sometimes, like in one large simulation model, there were situations where I wanted to catch an exception and then rethrow it. So it's like playing catch. And then just kind of as the little extra thing that for some reason the book doesn't cover, there's this thing called printf, which I found to be kind of a nicer way to do some of the output. So we'll get to that. So basically, it seems to be a law of nature that every piece of software that is above a certain size has something wrong with it. That is, I forget exactly which one it was. It was some major piece of software. It might have even been like an operating system or something. But there were some known bugs in it, and what they found was that every time they tried to fix it, they would just introduce other ones, and it was one of these sort of really kind of rare things. But the fact is that every piece of software above a certain size has something that can go wrong. Sometimes sometimes there are situations where the program, something will go wrong, and it's not the code's fault, and that is almost always the case when you're reading data from the outside. And every major program typically exists like that. In other words, you're reading in data, and when you're reading in data, there's always the opportunity that what you're reading in is garbage. And so what do you do? What do you do if the user, and that's true whether it's like a desktop program such as we're dealing with here, or you're a web program. So I guess the saying, the quip is that software is a race between software developers to write more idiot-proof programs and the universe to produce more idiots. But so far, the universe is winning. Anyway, the point is that in writing the program, you want to be able to to handle any one of these exceptional situations that arises. One of the advantages of a compiled program, such as Java, over an interpreted program, such as Python or JavaScript, is that the compiler picks up many of these errors before you even get to run the program. So all syntax errors cannot exist in a running program. Well, it's actually possible to kind of do that when you're working with some libraries, but that's not where. As far as the code itself goes, as you've noticed, no doubt, that NetBeans gives you the red squiggly of death if you have something that is not legitimate syntax. So all of those errors are covered by the compiler. All of the other ones, what we're dealing with here, are runtime errors, and runtime errors are ones that obviously happen at runtime. So, so the idea is that as much as possible, you want to anticipate what kind of things are going to go wrong, and deal with it. So what do you do if the problem is a fatal one, in that if this error, if this exception occurs, there's no point in even trying to run the program, then it exits. And you want to be as user-friendly as possible. So what does user-friendly mean in a situation where the program has crashed? I mean, so you're running a program and it blows up. So what do you want to know?
Why?
Yeah, why? What happened, why, and how can I fix it, and where did it go wrong? So when you're writing these, you want to be as user-friendly as possible. In other words, to let the user know, this is what happened, this is why it went wrong, and this is where it happened. So all of that is basically what's okay. So now Java uses a class hierarchy to deal with this. And so now that you know all about class hierarchies, you can kind of get this. So at the very top is something called a throwable. The throwable is it's actually a concrete class, so you can actually instantiate a throwable, although you can catch something that's just sort of a throwable, but that's not usually very informative. As you notice, it kind of bifurcates into two types of things. There are errors, or exceptions. So what's the difference between an error and exception? An error is something which has gone wrong system-wide. It could be things like the Java virtual machine that you're running has a bug in it, and somehow it crashes. That's never happened to me, but I suppose in principle it could happen, because the Java virtual machine is a large program, and the reason why you keep getting these updates is because people find and fix these little bugs. So why release? Why are all these programs being released and even sold when they have bugs in them? Well, in a large program, a lot of times it takes a certain very rare set of conditions in order for it to actually occur. But it does occur. Okay, so in my experience, the main errors really the most common one is a Stack Overflow. What's going on with that? Now, as you all are no doubt aware, the computer has memory that it uses to actually run things. The Java virtual machine creates this thing called a sandbox, and that sandbox is only a certain size. In other words, and I forget what the default is, but it's big enough so it will handle everything that we deal with in this course and even the next course. But when you're writing large programs that kind of do a lot of things, literally have hundreds of thousands or even millions of objects running around, you can basically fill up the heap. And so when you instantiate an object, then way behind the scenes, what it has to do is it has to go find some memory, allocate memory to that in order to hold the data for the object. So what does it do? What happens when there's no room to do that? In other words, it runs out of space. Well, that's when you get one of these errors. That's the only error that I've encountered in running programs. But you know, some of the big programs that I've created, you know, they've overflowed the default size of the virtual machine, which I forget what it is, because now with these kind of smaller programs, the default size is fine. For my bigger ones, what I have to do is I have to explicitly tell the virtual machine to create a bigger sandbox. I think I'm trying to think of the big. I think the biggest one I had to do was like 32 gigs of memory. So anyway, so those are the errors. The exceptions, you know, so as on the programming side, you don't have to worry about that. Okay, the exceptions, this is where we have to worry about it. And there are exceptions bifurcate into two types. There's a subclass of exception called runtime exception, and those are the unchecked ones. Those are the ones that we've encountered so far. And then checked exceptions, what that means is that if a method throws an exception, a checked exception, that means you have to explicitly deal with that. And as we'll see, there are two ways of dealing with it. So at the very top, we have throwable, and that handles all the errors. So at runtime, the virtual machine explicitly creates these, you know, in the throw keyword, and yeah, so that's the error things, as I said. So again, errors are like, the problem is either in the system, scarcity of system resources, and when that happens, there's no hope. So like when the virtual machine runs out of memory, you just can't proceed. They're unchecked, meaning that you don't have to, you don't know where they're going to happen or why they're going to happen, and so you can't really deal with them in the program. So the exceptions, they can appear at runtime. Well, the checked ones appear at compile time when you don't actually handle it. In other words, if you don't catch or throw a checked exception, then the compiler won't let you by. Now, it's possible to recover from that. So here's an example. Might be if we're prompting the user on the to enter something. Say enter a number, and the user can enter something that's not a number. And so what do? So you say, well, you know, hey, that wasn't a number, go away. Or you can say, hey, that wasn't a number, try again. Okay, which one is it? Well, again, that's kind of up to you. So you can recover from an exception, and that's when you catch it and continue, or you, in almost all other cases, it's like, hey, this thing happened, there's garbage on the input, we can't handle it. So if I'm reading a file and the file has to have a certain format, and like sort of it's got a name and then an integer and then a floating point number and then another number that has to be within a certain range, et cetera, et cetera. The program has no control over the integrity of that data coming in. And so if I'm trying to read a file and I need the data from that file in order to run my program, and the data is garbage, then the program is, there's no point in trying to run the program until I fix the data. Okay, so the unchecked exceptions are subclasses of runtime. We've encountered at least two of these. One is the array index out of bounds exception, and the most common exception, which is actually our friend, is the null pointer exception. Have you gotten a null pointer exception yet? No, not yet. Okay, well, you will. Um, or maybe not. Maybe it's just me, but that's my most common exception. And when we get these, you know, so they just kind of pop up, and we didn't have to deal with them at all. So the checked exceptions are the subclass of exception, but not runtime exception. So in other words, checked exceptions are direct subclass of exception, whereas the unchecked ones are a subclass of runtime exceptions. So they have to be explicitly dealt with, and the two ways of handling them are to throw it, which is kind of to that's kind of that's not my job thing. It says, hey, you know, hey, this thing's going to happen, and I'm going to make somebody else deal with it, or I'm going to surround it with a try-catch block. So the keywords that we see, so throws indicates that a method may throw an exception, and we'll see how to define that. NetBeans can actually kind of help us with all of these. The try-catch block, what we do there is that if we have some code that could throw a checked exception, so what could cause that to happen? By invoking a method on an object where that method declared it threw a checked exception. So it said, throws file not found exception. So we got to catch that and deal with that. In fact, we'll see an example of that. Now, because kind of weird things can happen, the finally block is something which is important to have in many circumstances, because what the finally block does is that kind of cleans things up. In other words, in our use case, the principle of using system resources, like for the scanner class is typically using system resources. So if we're reading a file, what it basically has to do is has to kind of find the file, open the file, and start reading from the file. And then when you're finished with that, you're supposed to close the file. I mean, it's just like if you're editing, say, a Word document, and you haven't saved it, then it hasn't been written to the file system. So that's happening when, say if we're using Scanner or anything else to read from a file, then that system resources is being utilized. And that's something which, in small programs, it's not so important. In large programs, that can also create an error. In other words, if you start utilizing more system resources, like say from the file system and others that are not, you kind of run out of stuff. In other words, there's only a finite amount of things, even on these big computers. I mean, so what finally does, in the little example, I'll kind of show you what's. If the principle is that if we leave a file open, then it's possible that be corrupted if our program crashes unexpectedly. So it's not a good thing to leave files open. And so we want to make sure we close it. If you notice that when we've used the scanner class, when we've instantiated the scanner, starting reading from it, we always say scanner, we close it. What that does is that kind of releases the system resources. So what do you do if an exception gets thrown, and then all of a sudden the processing exits from your normal sequence and into this catch block? And if that's all you do, and then you may have a system resource which is not being released. That's a typical use case. What finally does is finally is a block that executes even if an exception gets thrown, and we'll see an example of that. Okay, so here's sort of the little use case. So we're reading from an input file using our scanner class. You know, what could possibly go wrong? Well, one thing is that the input file doesn't exist. So how can you read from a file that doesn't exist? And how does the program know whether the file exists or not? That's something you can test for, but if it doesn't exist, then scanner does throw an exception, and so that's something that has to be dealt with. Another, even if we get that, we start reading from the file and it's trying to read an int that it isn't an int. So that's another exception that can be thrown. An alternative to that, instead of kind of relying on the scanner to do the parsing, what I usually do is I'll read stuff as a string and then try to parse the string. And whenever you're trying to parse a string into something, say that should be a number, what do you do if it's not a number? Again, actually an unchecked exception gets thrown there. Okay, so what can we do? We can check if the file exists and throw a file not found exception if it's not. And then we can surround the scanner with a try and catch and then use the finally block to close the scanner. So let's see what that actually looks like. And let's see, do I have a, oops, I don't want you. Let's, see, did I add? Yeah, okay, well here's, actually here's, I had this little snakes and ladders input there that actually had some numbers. Let me, okay, here's how, this is a pattern that I like to use. So, what I'm going to do is I'm going to look for the name of the file on the command line. And how do I know if something's on the command line? Well, there's this args parameter that's been passed. And so I'm going to say if you're bigger than 0, I'm going to just say that that's going to be the name of the file. And then give me some sort of default. Okay, I'll do the input. What did I call it? Okay, so now we okay, again, red squiggly here, cannot find it. Do they even give a suggestion? We can get add import, yeah. So either do it that way or right click, say fix imports. We're gonna, later we're gonna delve into a more deep dive into what this file object does. But it's very, it's actually very useful. We can check to see whether it exists or not. One of the things, if it exists, let's say if it doesn't exist, then, well, what I want to do is, see, I prefer, and for some reason it makes me, okay, so if it doesn't exist, then Okay, let's. Actually, okay, first I'm going to say logger severe. Let's just do it, file out. And then now, what I want to do is I want to say what didn't exist. And what I can actually do is I can get the, I'll get the path. I get absolute path. Absolute, it wants absolute file. Why aren't you? Okay, what are you complaining about? You're saying unrecorded exception must be declared or caught. So let me say that I will throw the file not found exception. So here's an example of throwing it. So I'm going to throw this exception if the file's not found, and tell you exactly where the file should have been. Now, for the Java doc, I also want to say what it's going to do. I'm going to throw a file not found exception if input file not found. Again, this is okay. So so what we otherwise, well, what can we do? We can say that here's what we found. Okay, so now if we run it, then it will say that we found it. All right, so now, but let's, in order to run it from the command line, okay, let's run that. And now if I run it without anything, it'll be the same thing. It'll create the default, but then supposing I want to give it something that doesn't exist. Okay, so I'm going to give it this file that doesn't exist. And now, okay, so my logger says it's not found, but here I'm saying this, I was looking for this file, it didn't find it, and then basically that's what happened. All right, so what I want to do is I want to read from the file. Let's see, okay. Now I'm doing it this way for a specific, okay, so scanner input file, and then so let's say I want to read a double value. No, let's read an int. Now, what could go wrong here? So let's do it. Let me create another input file. Let's see, was it other empty file? Okay. So, right, and let's make that the default. What are you doing? Okay, so let's see what happened. So we found the file, and I went to read it, but I got an input mismatch exception, oops, from here. Why? It was thrown by something in the scanner class. So what can I do? I can try catch it. Now, this was an unchecked exception. And so here's how I catch it. I wrap in a try catch. Oops, input, mismatch exception, says it can't find it. Let's add an import for it. All right, so now what do we do with this? Well, what I, now the book does a print stack trace, which that's kind of an old, antiquated way of dealing with this. What's better is to basically log the message, and if we really want to kind of throw it again. In other words, this has happened, and then, so if we want to say, okay, I realize this happened, but whoever called this method also needs to know something about it. So I don't want to kind of trap the exception and not let somebody else know. So I'm going to rethrow it. And because it's what I can do is I can kind of wrap the runtime exception in, I can wrap the other one in that. And I want to do, however, I want to release the system resources like that. So in other words, and then here just to I'll just let you know what I'm doing. And as that was kind of showing previously, the reason these using a logger instead of a print line is a better way to deal with things, because we can turn the logging on and off, and we can kind of have logs at here I have a severe one, here I have informational ones, and if I don't want to see that, I can just turn the whole thing off. And on top of that, maybe at some point we'll kind of delve a little bit more deeply into this. We can really customize this to the point where the default on this is that it only sends these log messages to the console, but I can actually direct them to files. I can format those files in a number of different ways. I can create XML documents where I can have a very extensive report on everything that happened, and also any errors that might have occurred, and those are extremely useful. So, okay, so here, okay, since I'm rethrowing the exception, here's what happened. Let's kind of, so first it found the file that was there, and then notice the other thing is that the logger also tells you where, I mean, if in a bigger program you'd have a lot of different methods. This tells you which method and which class the thing came from. That's why you tell the logger, by the way, this, giving it this information tells the logger which class all of the log messages come from. So and again, this is another sort of peek ahead, every class has, and this is every class, when it's loaded into the virtual machine, it actually creates an object for that class, and the the class that creates the objects for the class is called class. And for every class that's created in this way has a a static variable called class that references the class object that was created for that class. Could you parse what I just said? No. In this case, what I'm calling exceptional, this is the name of a class. When the virtual machine, how does the virtual machine know what's going on? The terminology is it loads the class. So when I go to run this, it encounters this class. It says, okay, I'm going to create this class. And in the process of creating the class, what do you need to do to create the class? Well, you have variables, the static, and you have methods. So it needs to create space for the variables, and it needs to create space for the logic of the method. So when you call the method, it actually goes to a sequence of calls in the registers that execute the various code, which is the machine instructions that have been created for this. So this is actually an object which refers to the class that's been created, and it has a name. And so if I use that to tell, what I'm doing is I'm telling the logger all of the log messages that come from this class are going to be tagged by that, and you can see that here. So see here in the log message, this is the class it came from, and this is the method that it came from. That's that's good information. Okay, so what happened here? It found the file, and then severe null. Okay, that was, where did that happen? Not sure. Okay, so somehow, where are we here? Scanner. Yeah. So for the input mismatch, that's basically where it said null. But then here it said, here's the finally. It released the file, and then this is where I re-threw it. Now, if I didn't throw it, it would just kind of sit there. Okay, so why rethrow it? Well, okay, now if I do this, I need to know, okay, I notice that, okay, here in my log, something sort of happened. And this isn't terribly informational. I thought it was supposed to be informational, but evidently when I'm trying to read this thing, the message that it kind of threw somehow, let's see, this was null, and so somehow this didn't have a message. That's kind of the fault of the library. But when I rethrow it, this kind of tells me a little bit more than what's happening. Whereas here, like if I run it with the snakes and ladders thing, then I don't get the error. So what I can do is, what was it? So again, if I run it and it actually works, then, oops, cannot find, where are you here? Oh, input value. Okay, so it found the value there. Okay, so try, catch, finally, and throw it or not throw it. Again, that's kind of up to the programmer. Okay, so Now I want to talk about this printf because basically what happened when Java came out, they had print and print line. Print line, as we've seen, that's what we mostly use. That a print line would print a string. The format is just a string, and so you just have to kind of create a string in there. Although a string or a number it's kind of overloaded, but it will print it and then move to the next line. Whereas print by itself does not move to the next line. As we've seen examples of that. I don't know if I pointed them out. So that's originally all we had. And now the thing is that C programmers, especially the Java folk, wanted to kind of convert. They were used to a formatted output called printf. And so at some point, what's interesting, a lot of the features in Java, some of which are good and some of which are not so good, are kind of come in response to kind of the fan demands, as it were. Some of those have been not so great, but anyway. But this was one of the good ones. Printf is actually what you may have noticed is that the previous way of the alternative way of formatting, there are these number formatics, objects that you can create, and that's a bit of overkill for a lot of stuff that you want to deal with. So printf is kind of a nice way of doing it, and its format is as follows. You give a format string, and then you give this is something which again, for some reason the book doesn't talk about. It's called var_args. This was something I'll cover in a little more detail later in the course, but it turns out that, and this was kind of in response to something that was requested. It wasn't in the original language. There are some circumstances in which you want to have a variable length, variable number of arguments. So far, when we define a method, we have to give it a specific number and type of arguments, and we have to kind of hardwire that in. But there are some circumstances in which, what if an argument is optional? What if I don't want to give an argument? Or what if I want to give, for the same method, I want to have like maybe one argument or two arguments or three arguments? Well, you can actually do that. And this is an example of that. So you give one format string followed by a variable number of arguments. And that format string it's its own little mini language, and it's especially useful for numbers. So percent is kind of is the escape character for this. So a %d gives an integer value. %f is a floating point value, meaning there's going to be a decimal point. There's a %string that gives a string value. There are some others. There's %b for Boolean. There's also, now, printf, like print, doesn't give a new line. So if I want a new line, I have to give it explicitly, and that is %n gives a new line. And there are a couple others, but these are the main ones. And on top of that, I'll tell you, do I have it up here? Yeah, there it is. Okay, so there's a handout that in the handouts part of the resources, and there are kind of these about justifications. A comma group separator. So like if I'm printing a number and it has more than 3 places, I can separate those with a comma. Here are the conversion, so we have %d, f, a character, string, hash code, and then the new line. So some examples of this are, so I say printf, and here's the format string. So this is an integer. So %d says print an integer. %n says give me a new line. And then here's a big integer. So now here's where the comma comes in. If I don't put the comma in, it'll just kind of print all the the digits. If I put the comma in, it's going to separate them out by threes. So this will print a number, and if there aren't more than threes, it won't put the comma in, and then here's a new line. So the output of this is, here's the 42, and then here's the big number. This happens to be the max value for an integer, and notice that it put the commas in. Now, one cool thing about this, which is that in different countries, they have different conventions for this. So in this country, and in some others, it's the comma that separates these. But in others, there's a decimal point that separates those. So, okay, yeah, so now for floating point numbers, the same thing happens. It is optional to give the number of decimals. But if here what I'm saying is I want 4 decimal places, and for, sort of a dot 4 is the thing. If I leave that off, it'll just kind of print whatever. And if I have a big floating point number, so here's a big floating point number I want with 4 decimal places and separated by commas. So here's this one. This is pi to 4 spaces. If I leave the dot 4 off, it will just print the whole thing. And so here's a big floating point number. I was going to use the double one, but that would be kind of out into the hall. Okay, but notice it gives the commas, but then gives me 4 decimal places here. But, okay, what if I was somewhere else? So here, if I was in Germany, and I wanted to print that, I can use what's called a locale. So in this case, there's a locale, actually for almost all the countries, and what it will do is it will print the number using the conventions of whatever that locale happens to be. So in this case, in Germany, if I'm printing a big number like this, it will use a decimal point to separate the places to the left of the decimal, and it will use a comma to indicate the things to the right, right? So what's nice about that is that now you can write your program in such a way that that whatever the convention is, it can use that one. In other words, you can set it up so that this can be sort of read in from where you're coming from. And so you don't have to kind of hardwire in different things for different countries or different conventions. You know, whatever the convention is, the code is exactly the same. I'm still saying I use a comma to indicate the things to the left of the decimal, and a decimal point to indicate how many decimal points I want, but it will use whatever locale is there to actually print what's going on. So that's kind of nice. So I encourage you to use printf for things that are, you know, in that situation. And the other thing is that they added that capability to string. So there's string.format. If I do that, then even if I'm not printing, what this will do is this will create a string using the same formatting conventions. Yes?
What's the difference between the %n and \n?
Well, in this context, I have to use the %n. A \n won't work, but a \t will work. It just different, you know, print line uses the \n thing. I'm not sure why they use the %n for this, but same thing.
So why would you want to use instances where we are not
Well, let's say, here's like supposing the two string, think of the two string for the playing card. I mean, that wasn't sort of a big deal, but it was like, here I would say something like string format, and I would say something like, I would say %s of %s. And then I would give the suit, no, I'm sorry, I'd give the value, and then the suit, and then I would return a string dot format of that. So whenever I want a string that's the, so if I'm writing data to a file and I want to format in a particular, so let's say this actually comes up a bunch sometimes, where the computations create these long decimals to the right, and I only want to print 4 of them. But I'm saving it to a file. And so this allows me to format the output of the file in a, I have complete control over it. Okay, so that's it for today. We're going to continue, just some last little bits on exceptions, and then we were going to move on to the, to actually, what my favorite part of the thing is the collections framework. So.